started? Here we go. Today, the 21st, our second of 3 lectures on Chapter 4. And then we start Chapter 6 next week. We got Tuesday finishing this chapter. We start Chapter 6 Thursday next week. Spring break. Long pause. And then we get back to Chapter 6, then Quiz 3. Did I mention spring break? What are we doing? What are we doing? What are we doing?
You were giving us an A, so we all go home.
You go. Anyone can go back. No way. You ready? Let's look at this. This is a perfect example of what you should expect, possibly even on the quiz. Now, the question, if you see this up, something like this up there on the quiz, the question is going to say, write the linear programming model. And I want to make sure you know what linear programming model means. It means it's asking for you to identify the variables. Not just say x1, but what does x1 equal, or x2, or whatever variables you want to use. Identify the variables and define them. Write the objective function, write the constraints. That's a linear programming model, and you're going to see this a lot, including your homework that's due when? Tomorrow? What's tomorrow? Right?
Yes.
So it can't be due tomorrow, right? No, what's going to happen is your homework's due Thursday, but it's a kind of a larger homework assignment, so I want to give you a chance to get started early. So I'm going to give part of it today at the end of the lecture, and I'm going to post the first 2 problems that I'm telling you about on Blackboard, so you can get started early if you want to. It's kind of a longer homework assignment. It's going to be at least 4 problems. All of them, you're identifying the linear programming model, which means you're identifying the objective function and constraints, and you're identifying the decision variables. That's what a linear programming model means. All the homework is going to be doing just that, just like this. This is an example of how it's used in management, very micro example. This would be more like if you have a whole bunch of employees to schedule. And believe it or not, some of you, even if you're not a business major, will end up, your destiny is going to head you towards management. A whole bunch of you don't even realize it right now. And when you're in management, one of the most common duties is scheduling the employees. So the goal is to keep the cost of labor as low as possible, to schedule the least amount of employees necessary to fulfill these requirements. And these requirements say, however many employees you schedule starting at any of these times, there needs to be at least this many during that 4-hour period. But keep in mind, when you schedule an employee, whatever time they start, they're there for 8 hours. Does everybody get what I just said? So do you see, but do you see the start times? They're every 4 hours. So I want you to see the logic behind this. If you schedule 2 employees at 8 a.m., well, there better be 3 employees at least that got scheduled at 4 a.m. that are hanging on until noon to fulfill this minimum of 5. Get it? So, all right. Let's look at this. You have the task to schedule employees. You've just been handed the following information. You're asked to determine the number of employees that should be scheduled for the 8-hour shift starting at one of the following start times. You see, you have 1, 2, 3, 4, 5, 6 different start times. It says you've also been told that there needs to be a minimum number of employees during each of the following 4-hour time periods. So this is the minimum that need to be there. If you end up with 11 here, it doesn't matter, as long as there's at least 10 to fulfill what's needed during those 4-hour periods. Think about this. Is anybody ready to commit as to how many decision variables there might be? Anybody?
6.
I like 6. Anyone? Go ahead. Explain, Nick.
For every shift, probably.
Every shift. The decision is, how many employees are you scheduling for each shift? What would be the optimal number of employees to schedule for each shift? All right, so there's the decisions. X1, X2, X3, X4, X5, X6. We'll go ahead and say, keep them in this order so that we're all on the same page. X1 means this is how many you're scheduling for this time period. X2, X3, X4, X5, X6. Now, What about a constraint? Do you see a limitation? Name one.
It can only be 8-hour shifts.
I see your point. They can only be 8-hour shifts, or they have to be 8-hour shifts, really. They can only be 8-hour shifts. I like that. But what I'm trying to get at is these are the limitations that you've got to adhere to. I want to take it one step farther. The right-hand side of each of these limitations are easy. You know it's going to be either less than equal, greater than equal, or equal. What does this 5 represent? How many we have to have, or minimum amount. So this constraint right there for the number 5, is that going to be less than equal, greater than equal, or equal? Exactly. Is that your turn?
No,
Did you say?
that was me.
Greater than equal. Because this is the least we need. Something, something, something greater than equal to 5. You can't have less than that. Jump in, Chase.
It doesn't say that there's a constraint on the number of employees that you have available, so couldn't you?
That's right.
And
You have a limited number. The goal is that schedule the least number possible, because that will keep our costs down.
No, it just says to schedule them so at least the minimum is met.
That's right.
It doesn't say to minimize the number of employees employed at
I'll add that now.
So I could just hire.
The goal is to have the least amount of employees, keep costs low, and that's the goal in management all the time. Even the littlest decision that you need a new printer or a print cartridge, the goal of management is to keep your costs as low as possible. You got to stay on budget or below it. Right? How many constraints do you see right there?
6.
That's right. Tell me the 5 again. What'd you say? Was it less than? Greater than equal to 5. 6? Greater than equal to 6. Someone I heard? 10? Greater than equal to 10. Give me another. 7. 4. Another 6. 1, 2. There's the 6 constraints. Only a certain amount of employees available. If it said, hey, we only have 40 employees, you can't schedule more than 40 or something like that, we'd have another constraint. If it said, we have a contract in place that we have at least 20 employees that have to be scheduled, that would be another constraint, right? Greater than equal 20, only 40 available, less than equal 40. You're looking at the sentences, you're looking at what the limitations are. Now we have to take the variables you told me that exist, x1, x2, x3, x4. Real quick, let's define x1. Because when you're doing these linear programming models that you're going to have in your homework, you have to tell me which variable you're using and what it equals. Define it. Give me what it equals. x1 equals what? What is x1 equal? And it has to do with this. The number of, or how many employees are going to start at 8 a.m. That's x1. How many? How many employees are going to start at noon? How many employees are going to start at 4 p.m.? You get it? Everybody with me? Now, I want to give you a hint. If you were doing this manually, this isn't that hard. And what will happen is, there'll probably be about 3 or 4 different answers here. And there are at least 2 or 3 that will be the same optimal minimization, which gets to our objective function, which means there's more than one optimal solution. But once you find the optimal solution, even though you may have another optimal solution, you'll never find another solution to beat the objective function value. They'll all tie it. Now, let's talk about the objective function. Max or min? Min. And we're trying to minimize what? Not just, I don't see any cost in there. The number of employees that we're scheduling, which will turn into cost. Right? The less employees you schedule, the less it's going to cost. Which is, everything that you're doing has to do with cost. But in this case, we're minimizing min. Now we have to turn this objective function into the number of employees we're scheduling.
So x1
And relate it to the variables. Say it again.
x1 plus x2 plus x3.
Plus x3, plus x4. x1 represents the number of employees we're scheduling at 8. Plus x2, the number of employees we're scheduling at noon. Plus x3, the number of employees at 4 p.m., and so on and so on. all added together would be the number of employees we're scheduling total, and that's what we're minimizing. So I have x1 plus x2 plus x3 plus x4, 5, 6. I'm invading the space of this last constraint, but we're okay. Can everybody see that? Even those kind of behind things?
No.
You can't, but you heard me?
Computer's in the way.
Let's write it. Minimize x1 plus x2. By the way, I'm posting this with the answer in case you don't want, you're getting tired of taking notes. All right? I'm going to post the answer of this. All right, so let's go with the first constraint. Greater than or equal to 5. We have to turn the variables, all of them, some of them, whatever we're going to use, and they got to represent this 5. Now this 5 doesn't represent how many you're scheduling at 8 a.m. It represents how many employees need to be working during that shift. And sure, the employees you schedule at 8 a.m. are working during that shift, but who else is working during that shift?
Or 4 a.m.
The ones you're at 4 a.m. What about midnight? Are they working that shift?
No.
So they wouldn't be part of the 5 if we were trying to figure out how many we're scheduling during that 4-hour period? So it's just this variable and that variable? Let's do it then. Just as your observation is, x1 plus x6 has to be greater than or equal to 5. However many we schedule at 4 a.m. plus however many we schedule at 8 a.m., they're both going to be there during that 4-hour period from 8 to noon. And when I add them together, they need to be at least 5 of them. Right? Now that you see that logic, it makes every other constraint very easy. Because you look at this shift here from noon to 4 and you go, okay, which variables represent the employees that would be there during that shift? Obviously x2, but what else? x1. x1 plus x2 greater than or equal to 6. 10. x2 plus x3 greater than or equal to 10. 7. x3 plus x4 greater than or equal to 7. 4. Justin's got it. x4 plus x5, x5 plus x6. Did you get it? All right, let's take a look. Make sure we got this. That's the whole thing. There's our variables, x1 through x6. There's our objective function, adding however many employees we're scheduling all together. There is our constraint for 8 a.m. to noon to make sure we have 5. However many are scheduled way back at 4 a.m., plus however many are coming on shift at 8 a.m. The ones at 4 a.m. are sticking around for the last half of the shift. The ones at 8 a.m. are there for the first half of the shift. Added together got to be 5. We go to the next 4 hours. The ones that were scheduled at 8 a.m. are sticking around for the second half of their shift. The ones scheduled at noon are there for the first half of their shift. Added together, it got to be greater than 6. Same, same, same. You ready? Hang on, I got to remember what I'm doing here. Boom. Look at this. However many are scheduled at 8 a.m. plus however many got scheduled back at 4 a.m., we've got to have 5. 8 a.m. and noon, got to have 6. Noon and 4 p.m., got to have 10, and so on. 1, 2, 3, 4, 5, 6. Right here, this will be telling us what? What will this tell us when we have the numbers there?
Amount of people per shift.
How many people to schedule for each shift in order to make sure that you're scheduling the minimum amount of employees, keeping you under budget, which will allow you, I want to connect it back to you, which will allow you to be able to ask for the biggest raise, to get the biggest bonus at Christmas, blah, 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 blah. I can't tell you how many times I'd be out to lunch. I wasn't the president of the company. I would go out to lunch with the president of the company, and we would work out everybody's Christmas bonus and everybody's raise having lunch. And it's so subjective to the point to where you got to be ready. It only comes up once a year, and you got to be ready with what did you do that's over and above what the average employee does. What is it that you did that's over and above? That's what gets the extra. That's what, I don't know, if you have the ambition to move, that's what does it. So let's do this. What about this? What is, just give me an idea. Anybody feel confident they know what would be entered there if I were to click on there using cell locations? Right there. That's right. No. 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 18. No. That is 18.
E16.
16
F16.
time plus times 12. 16 times 12, right? This cell times that cell plus this cell times that cell plus this cell. We're doing exactly what's being done here. Yeah, no, there's a 1 in front of each of these. 1, 1, 1. There's your objective function right there. So let me get the cell locations to make sure. E12 times E16, F12 times F16, G12 times G16, and so on. That's just before we solve this. I want to make sure we get this right here. You can't even see it. Hang on a minute. Right there. What is entered in that cell? Just get me started here. E what? I never heard of it.
Is that constraint 3?
That's constraint 3. Look, I'm even showing the number system.
E8?
E8, very good. Times
E16.
E16 plus F8 times plus G plus H plus I plus J. Exactly. Wait a minute. I got it up there? No. Okay. Hang on a minute. All right. I didn't. There. E8 times E16, F8 times F16, G8 times G16, and so on and so on. There they are. Let's solve it. Solver. Wait. Data. Solver. Look, there's no numbers. What do I put here in set objective? Which is where?
E18.
Thank you. Is this a max or a min? Go over here, hit min. By changing variable cells, which cells?
E16.
Thank you. Right there, E16 through J16. Here we go with constraints. All right. Hang on, you can't even see cell locations. Hang on, let me get over here. Darn it. Hang on. I'm going to have to move after you tell me. The first constraint is what cell location?
E22.
E22, then greater than, less than, equal? Greater than, and then what cell location? Now, here's a shortcut. Is it possible we have a few greater than equals in a row?
Yeah.
We can combine them. If they're in a row, we can say F, what is that, E? E22 through E27 greater than L22 through L27. In one constraint, you can only do this when they're all the exact same direction. So I'm going to show you the shortcut now that we're there. Look, I'm going to put it right here, and I'm still not going to be able to see. Darn. That's one.
Shorten the box a little bit.
How about this?
There you go.
Thank you. Here we go. Left side, I'm going to do this whole, all 6 of them. Put this at greater than equal. The right side, I'm going to do all 6 of these, because all of them are greater than equal, correct? Okay, and then I put okay. So we did all 6 constraints in one move. Saved a ton of time. You can't do this if any of these were equal or less than equal. You can only combine like equalities. What do I do here? Check the box, and what else? What about this?
Sorry. It's already on there.
Okay, just checking. It's the only one I didn't get to it. Here we go. Has anybody figured out how many employees? Any? 19? Good for you.
What happens if we don't click the box? How will that change the answer?
You could get negative answers and negative numbers. You want to try? It may say unsolvable. I'm not sure. Here we go. How many did you say? 19?
19.
Do you have how many per shift and everything? Even though there's more than one right answer. You do? Okay, see if this is the same or not, because I can tell you don't want to tell me. Did I just solve already? 5, 1, 9, see, -2. There's no way a -2 is going to, so let me go back to that. So the way to redo this, you take these and make them all zeros again. That's it, and then you get, here we go, we'll do it again, solver. Now we're checking the box. Let's do this again, now check it. Ready? 19. 19 employees, the least you're going to get. And this may not be, you may have a different combination.
That's what I got.
Oh, really?
Yeah.
337-042. Make sure you drive easy, get the schedule done, move on to the next thing. All right? What's nice is you're going to have all these examples because if this, about 5 years from now, this is going to come up in building. All right.
Wait,
Yeah.
so is it
scheduled, that there's enough being carried over from this shift to cover the amount needed. Because they're there for 8 hours. Let me go back real quick to X3. Which one's X3? So there's enough, there's 3 from the previous shift for this 4 p.m., 7 more coming on, those 7 hang out, and all that's needed is 7 for 8 p.m. So it covers it. Jonathan doesn't care. He's nice.
I do, I understand.
Yeah, all right. So now this is who cares? All right, you ready? Let's do another example. Marketing majors? Thank you. 1 person. Thank you. Thank you. Thank you. 2 people. I don't care what major you are, by the way. You're going to have some marketing and sales situations in your future, no matter what your major is, computer science, I don't care what your major is. Almost every business in every position has a little bit of sales involved, customer service, marketing, whether it be just for your individual department, whatever the case may be. So this one, though, specifically would be somebody who does the advertising and marketing for a company. And in this example, this company says, hey, we invented this new machine, and we want to do a test market before we go blow out and spend all this money to retool things to produce a whole bunch of them. So we just got enough of them. We went ahead and subcontracted to manufacturing. We got enough to do a test market to see if this will really work. We got a lot of money invested. And marketing, now it's up to you to collect the data of how well this is going to sell based on the test market in Dallas. So in Dallas, here's the deal. We're going to hand you $282,000 to do a weekend blitz for this product. Let's see how many orders come in. And this product is a salad machine, instant salad machine. Now, those don't exist yet. This is pretty innovative. An instant salad machine. You have $282,000 to spend, but here's the deal. There's only so much different opportunities to spend it on, and there's limitations how much that we want you to at least do this many news ads, this many sports ads, and that's what we're going through to see what happens. First of all, $282,000. Is that a limitation?
Yeah.
Less than equal, greater than equal, or equal? That's right. We cannot spend, and I want to tell you, marketing is the only department that will try their best to spend more than that, but we cannot spend more than $282,000?
Yeah.
Thank you. There we go. Let's keep reading, see if we can find another one. The product will be initially test marketed in Dallas. The money will be spent on TV advertising blitz during one weekend. So Friday, Saturday, Sunday,
X1, X2,
which means this is it, just these 3 days. And it'll be in November. The 3 options available are, here they go. And this is for each day. Daytime advertising on Friday. There's daytime advertising Saturday, daytime advertising Sunday. Evening news. There's the evening news Friday, Saturday, and Sunday. So there's 3 of those you can choose from. Sunday game time advertising. This one's only on Sunday. Okay, it's not every day. So we have, how many of possibilities do we have that I just mentioned?
7.
7, I see. And when there's more than 7.
More than 7.
That's it? So you're saying there's 3 daytime advertisings, there's 3 evening news, and 1 game time? Okay, all right. Let's name some. So you're saying there's a Friday, what is that, what was that, daytime? We'll call that daytime. Then there's a Friday evening, and then there's a Friday, is that news? No, there is no more Friday. Right?
Yeah, that's it.
Same thing for Saturday, same thing for Sunday, and then there's the game.
What about the news?
This is news. Friday day, evening news. There we go. Saturday, evening news. Look at that. Evening news. There, is that better? You ready? Here's what you're told. If you do a daytime ad, Friday, Saturday, or Sunday, you're probably going to reach about 3,000 people, and it costs $5,000. Evening news, you're going to reach about 4,000 people. It's going to cost $7,000. If you do a game ad, you're reaching out to 75,000 people at one time, possibly. But look at the price. You know, you have 282,000, so don't spend it all on the game. I guess you can. I don't know. Maybe. The company said, hey, we want you to do at least one ad of each type. At least one daytime ad, at least one evening news ad, and at least one game time ad. Tell me how many variables there are.
7.
And so if I said X1, how would you describe X1? X1 represents the what?
Friday, daytime.
The what of Friday daytime though?
How much or how many?
The what?
Like how much?
How much or how many? How many? Because it's not about how much you're spending. This will dictate how much you're spending. The variable itself is how many Friday daytime ads are you going to schedule? All right, so I'm going to call this X1 right here, and I'm going to put the word up here, how many. Because you got to remember this, how many, because now we got to transform these variables to meet the right-hand side, such as money. Do we know the price of every one of these ads right here?
Yes.
Well, whatever we're going to spend, however many we're going to schedule, when they add up, we can't go over budget. Go ahead, Doug. Are you going to jump in with that?
If we don't write how many, is that right or wrong?
Pretty lenient. But if you would have put how much, pretty lenient. I don't know. We'll see. Don't worry about it too much. But let's turn these variables into money. X1 is how many, but what will you do with X1 to turn it into how much you'll spend on Friday daytime ads? You multiply it times the 3,000, the cost of each daytime ad. No, not $3,000, $5,000. That's the number of people we'll reach. Okay, so for money, we're going to take 5,000 times X1 plus, what's this, X2? How much we're going to spend on an evening ad? Plus 7,000 times X2 plus, what's the next one? X3 is Saturday daytime ads. How much is that? 5,000 times X3. Do I need to keep going? Does everybody get this? How about this? Dot, dot, dot. Now get me to this one.
100,000.
Thank you.
X7.
Plus 100,000 times, what is that, X7?
7.
Thank you, X7. These ones between 3 and 7 are all going to have the same prices as you have, 5 and 7, 5, 7, 5, 7, 100. So there's taking the limitation in money and how much we'll spend into consideration. Let's keep reading. We want to take out at least one ad of each type. Let's start with daytime ads. Give me the variables that represent how many daytime, because that's a type, that you possibly could be taken out.
X1.
Plus
X1,
Plus
X3.
X2, or X3, sorry.
X3,
Plus X5.
X5. X1 plus X3 plus X5 represents the number of how many daytime ads we're going to schedule, which has to be at least what?
5,000.
No.
3,000.
One of each type, right? Does that say one?
Yeah.
So less than equal or greater than equal to one? At least one. So we have to have at least one. Let me read this again. Am I reading this wrong? Wants to take out at least one ad of each type. So it doesn't matter if it's Friday, Saturday, Sunday, as long as we have one daytime ad, right? One evening ad at least, and one, does that say one game time too?
Yeah.
Wow. Here we go. Give me the Friday evening, what would that be? X2 plus X4 plus X6 greater than equal to 1. And now what's the game date? Is that X7? And it's got to be greater than equal to 1? So we're blowing 100,000 no matter what? Wow. We got to have a meeting. And you'll have a lot of them. There are 10. Okay, but now further. There are only 2 game time spots available. That's good. So the most we'll spend is 200,000 at least. I got to represent that sentence. Give me what variable?
2.
Uh,
I'm sorry.
what variable represents game time? X7
Less than or equal to.
less than, greater than, equal, less than, equal to 2. There's only 2 available. If we schedule, and we know we're scheduling at least 1, we cannot schedule more than 2. Plus, we don't have the money to schedule more than 2. So that seems impossible. Then the next sentence says, there are 10 daytime spots and 6 evening spots available each day. Not all together, each day. how many daytime? 10. That's all it's available, right? So less than equal, greater than equal 10. Less than equal 10. This side has to represent Friday's daytime ads, because it's each day, right? So what represents Friday daytime? X1. Now what represents Saturday daytime? X3, less than what represents Sunday daytime? X5. The sentence says, let me make sure we got this. It says there are only 10 daytime spots daily. So we got that. Now we got to say, and there's only 6 evening news spots daily. Less than equals 6, greater than equal to 6. Okay, I'm going up here now. Less than equals 6, less than equal to 6, less than equal to 6, right? Is that what it was? Yeah. Give me the variable for Friday's evening. X2, Saturday's evening. X4, Sunday's evening. Oh, is that right? Just check. All right, let's keep reading. And there, that's it for that one. Good. The company's asking us, marketing, to have at least greater than equal, less than equal, at least 5 ads per day. No matter what kind of ad you run on Friday, we need at least 5.
Did you write like X1 plus X2 plus X3 less than or equal to like 30 and combine them all?
No.
No.
Because you could have then, you could have all 30 on X1. It wouldn't stop that from happening, because when you add them together, it's still going to be 30 or less.
Okay.
Yeah, you have to do them individually. Yeah.
So, because we have to have, what's it, 5 per day?
We have to have at least.
We have to have 2 different constraints to represent Friday, Saturday, and Sunday one, because X7 is available on US Sunday.
Yes. I think. I'm not sure I understood your question. I think it's going to be answered in just a second, though. After I say this constraint, then I'm going to see if I answered your question. Okay. It says he's trying to make the point that they want at least 5 ads per day, but it's whatever kind of ad you're going to do on Friday. And you said less than equal to 5 or greater than equal to 5?
Greater than.
Okay, so let's go over here. Greater than equal to 5, at least 5 ads per day, but now I need to know what represents the number of ads we'll have on, we got Friday, Saturday, Sunday. And what represents Friday? However many we schedule during the day on Friday, plus however many we schedule in the evening on Friday, they need to be at least 5. Saturday, give me the variable. However many we schedule on Saturday during the day, however many schedule on Friday during the day, Friday at night news, Saturday at night news, it's got to be greater than 5. Sunday, X5, X6 plus X7. Because they're all on Sunday, including that Sunday game time, it's got to be greater than equal to 5. How many constraints are we at? Because this is starting to.
Like 13.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 so far. Have we done the objective function?
No.
Oh, we haven't been told what it is yet, huh?
There's 2 more constraints here.
Yeah. Really, you guys get all right in front of you and I'm asking all these questions for nothing. Here we go. Okay, now, the management said do not spend more than $50,000 on Friday. Do not spend more than $50,000. Less than equal, greater than equal.
Less than.
All right, less than equal 50,000. This is going to be off camera. Shoot. Less than equal 50,000. We have to turn the variables. What day is this?
X1, X2.
Friday. We have to turn the variables into money, though. Yes, Friday variables are X1, X2, but this is money. All right, so this isn't about how many. The cost. 5,000 times X1, however many we're having during the day, plus 7,000 X2, however many evening on Friday. We can't spend more than $50,000 for Friday. Saturday, our limit's how much? Is that Saturday or Sunday? That's got to be Saturday. Yeah. $75,000, same concept. How many variables represent Saturday? 2. And the cost, and what are they real quick?
5,000.
5,000 X3, is that true?
Yep.
And then this is 7,000 X4?
Correct.
Okay. And then, that's it? That's it? That's all of them? Really? Let me look. There's our variables. 7 of them, just like you said. think we're missing one thing. Here's our objective function. Wait a minute, we skipped something.
Isn't our objective?
It doesn't say here, but you know what? We want to reach as many people as possible. Did we skip that sentence?
Yes.
Where is it?
Not in there.
Yeah, nobody's like,
Just like the last problem.
Well, what the heck? We want to reach as many people as possible. Min or max? Max. The variables are how many. So we have to convert the variables to the number of people we're reaching. So let me just get me started here. Max, again, it's behind here, you guys, sorry. Max, what's the first variable? 3,000 x1. The number in which that particular ad would reach if we scheduled a daytime Friday ad. It will reach 3,000, and however many of those, that's how many will reach with the daytime Friday ad, plus, is it 7,000? Oh, no. 4,000 x2, because that's how many we would reach for every evening ad. And then I would do 3,000 x3, 4,000 x4, 3,000 x5, 4,000 x6, and then what?
75,000.
Yeah, 75,000. I laugh because that's unbelievable. X7. We're using x's instead of whatever variables. Now we're done, right? And how many constraints was that again? 16?
15.
15? Wow. Here, don't argue. 3,000, 3,000, 3,000 is all the daytimes, Friday, Saturday, Sunday. Number we would reach. 4,000, 4,000, 4,000 are all the evening ads for each day. That's how many we would most likely reach. And there's the 75,000. That's what we're maximizing. We're staying within budget, 282,000. We want to reach as many people as possible. Here's all our constraints. We enter it into, where is it? Excel. You ready? Here it is, right? Hang on. This right here, this is constraint. A 1 should be with that first variable, a 1 with the third variable. Our variables are in a different order. Daytime, 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 where we have it, daytime, daytime, daytime. Okay, so you guys are just going to hypothetically assume I got this right. But notice, 1, 1, 10, 10, 10. How many sixes? 6, 6, 6. What are the next one? 2 and 5. 2. Where are the 5? Should be 3 5s, is that right?
Yeah.
And then what do we have? 50,000, 75,000. And what's that 200?
282,000.
Oh, our money. Thank you. Scroll down a little more. There's our objective function, 3,000, 3,000, 4,000, 4,000, 75,000. You ready? All right. Our answer is going to be there. What does this mean if this were a 5? 5 daytime Sunday ads should be what you schedule to meet all these limitations. That's what we're about to see. What if this right here says 342,000? What does that mean? That's how many people we're going to reach with this combination of ads to stay on budget, and that's the most people we can reach. Even if there's a different combination, it won't take us any more people. This is going to be the most. And management said, reach the most people possible. So here we go. Data. Solver. There we go. All right. Set objective right here. Justin, where are you? Come on. Set objective. Where are we? He's on top of this. Someone else. Help me.
28.
Thank you. All right. Max or min?
Max.
Changing variable cells.
E26.
E26 all the way to K. Thank you. Here we go. Now, are all the... Wow, let me get these constraints where we can see them. Darn, it's not going to let me. Oh, yeah. There we go. No, it's not going to let me. Darn. Well, let's start with the first 3. Are they all the same?
They are.
Yeah.
So I can combine those?
Yeah.
And does anybody know if the 4th one's the same?
No, it's not.
Okay, let's combine those 3. Ready? I'm going to go add. I'm going to take these first 3 right here. I'm going to make it greater than equal. Is that correct?
Correct.
And the right-hand side is going to be these 3 cells right here. And hit OK. And now we still can't go down. Yes. The next ones.
4 through 10.
7. Is that right?
That's constraint for it.
7 of them are all less than equal in a row.
Yeah.
Let's do all 7. Here we go. Add. Left-hand side, we're going to go from right here, it looks like, to right there. Is that right? Anybody? Right there?
Yeah.
Less than equal, the right side would be, I lost it already, right here, all the way to right there. Yep. So there's those. All right, we got those. Now, after that, we have
3.
just these 3, and then we have 3 again. Okay, let's do, they're the same direction, so we'll do, here we go. The left-hand side of these 3 is, am I right here?
Yep.
Thank you. And then that's a greater than equal, so I'll switch this. The right-hand side, right there, right there. Look at, I'm just getting, this is the first time you're going to see what happens here. Well, if I hit add, I'm not going back to check and make sure those get, I can just go right on to the next set then by hitting add. Now it's asking for the next ones, which are going to be, there's 16?
Yeah.
Less than equal, right-hand side, right here. Now, is this it? Well, let me scroll down. Okay. Are we done?
Check the box.
Oh, okay. All right. There we go. We learned what happens if we don't do that. And this, we're okay?
Yeah, you're good.
Okay. Here we go. How many game time ads are we going to schedule for the football game? For an instant salad machine? How many? Wait,
This is the wrong
how
problem.
many? What's wrong?
This
What's
is the
wrong?
last problem.
Oh, how'd that happen? Did I just solve it for this one? No, okay, here we go.
Yeah.
There we go. How many game time ads will we schedule? 2. Which will spend how much money then?
200,000.
No. I think they're 100 apiece, aren't they?
Yeah.
Yeah.
200,000 just there. I want to make sure you realize this, marketing majors. An instant salad machine and the most common audience watching the football game, yeah, they may not correlate with each other. That's the only bad part about this. How many news time ads? You have to have at least, where's my news time ads? You've got to have at least 5 of them, right? No, 5. 1. No, we don't have a.
There's no.
Is that it? We have to have at least 6. Do we have?
That's
That's evening Friday.
No.
Evening.
You
six.
just have to make sure you have 5 ads.
Oh, it could be less than. That's right, not at least. Okay.
Yeah.
Well, my question for you is, how many Saturday daytime ads are we going to process? All right. Very good. Right there, daytime Saturday. You know what's not hot? Here's the question: how many people are we going to reach? There's how many people we're going to reach, and that's the most we can reach. Even though there may be another combination that could reach that amount, there's no combination that stays within these constraints and reach more than that. That's it. That's the max. All right? We good? Everybody all on top of this? The only additional question I might ask right here, I got scared at it for a second, is how much are we spending? Now, this will take a little work, but does everybody see how you would get to the answer?
Yes.
You do. Help me out then. Jim, is that you?
So it'd be, you take 7 and you multiply it by the cost.
What is the cost for daytime Friday ads?
5,000.
Is it 5,000 or 3,000?
3,000.
5,000 times 7 plus
5 times 5,000.
5,000 times what?
5.
Is it 5,000 for the evening?
Yeah, daytime.
Yes. Oh, this is daytime? Sorry. 7 times 5,000, 5 times 5,000, 3 times 5,000, 1 times
7,000.
7,000, 0, 0, 0.
Yeah.
2 games, 2 games,
2 times 100,000.
All of the evening slots are.
I just want to check something.
The evening slots don't get you.
Are we having at least 5 ads on Saturday? Yes or no? Look at just Saturday. Because we have 5 during the day. That's why we don't have any evening. We are meeting that constraint. We're meeting all these constraints. You would add up this times their cost. Start right here with 200,000 and just add this a little bit. And what you should see is we're probably spending darn close to 282,000. Maybe exact.
Could you scroll down to like where it says you can get all the
Yeah.
constraints
Let's
and
see.
what that's
You
in?
ready? Which constraints are binding? Thank you.
Well, no, when it say like if you scroll down to like constraint 6, wouldn't that say how much you cost? Like you scroll like you
much are we spending? $282,000. Is it a binding constraint? What? What? Wait, come on. Is it a binding constraint? Yes, why? There's no slack or surplus. When the left-hand side is equal to the right-hand side, if we were to put the optimal solution in and we get this answer, and it equals that answer, there's no slack or surplus. There's a binding constraint. Do you see another binding constraint there? Which one? 12. They're the same. 13's the same. What about this? Well, let me go to 14. 14's not binding, correct?
Right.
Is it slack or surplus? Oh, there's a lot of hesitation in there. Come on, is it slack or surplus? We should all be on the same page. You know it's slack, right? Right there. How much slack is there?
8,000.
Very good. Just the difference, right there. Give me, is constraint 4 binding? Slack or surplus? How much?
3.
Okay. All right, you're good. Everyone's good. I think we're all back on the same page. How many did we just do? 2? All right, we're jumping now to financial. Any finance majors? Okay, sales is in your future.
Well, I'm already in sales right now anyway, so I'm going to do yours, so.
But I'm saying, did you know that?
Yeah.
All finance, when I talk to a finance major, and I say to them, you know, you realize sales is in your future. They kind of look at me like, well, what do you mean? You know, unless you're strictly at a huge company where you're a financial analyst who never has to work with humans. You know, a lot of finance majors go to a financial advisor or certified financial advisors, and they're working with customers. And sales is in your future. So you might as well, you know, finance majors, make sure you got a steady hand on how to sell something. I hate to say it, but even Edward Jones, when he started there, you got to go knock on doors of people you've never heard of or talked to and introduce yourself. For like the whole first 6 months. Has anybody ever heard of Edward Jones?
Yeah.
You know what I'm talking about? Okay, well, I'm just letting you know. Here we go. You ready? Finance majors, you got this situation. Let's see, what is it? You're located in New York. There's $100,000. Converting industrial, you have $100,000 in these bonds. You got to convert to cash. You're now looking for some other investment opportunities with these funds. Based on the current investments, I can't see it. The firm's top financial analyst recommends that all new investments be made in the oil industry, the steel industry, and government bonds. Those are your 3 choices. Let me just jump down here. Here are some oil choices and their expected projected yearly rate of return. Here's some steel, and that looks like government bond, and I can't see that.
4.5.
Is it 4.5?
Yeah.
I can't see it.
I'm in government bonds right now, and I'm so happy to get 2.1. I just died to get 4.5.
Is this in the book?
It might be. I'll tell you if you.
Okay.
The question says, let's see, what does it say here?
There's 3
Government bonds, specifically, the analysts identified the investment opportunities and projected their annual rates of return. The investments and rates of return are shown in this table. Management's asking you to follow these investment guidelines. Neither industry, oil or steel, should receive more than $50,000 of the money invested in there. Is that a limitation?
Yeah.
Yes.
50,000 less than or equal to?
Less than
I couldn't hear it.
Less than
Less than. Here we go. This one's gone. Man. You know, I need to just get some money out of my pocket and start paying people to help me. You ready? Less than equal to what again? 50,000? Okay, less than equal to 50,000. There's one. Or wait, is it more than one? 2, because there's 2 industries being talked about there.
Yes.
This one will represent either steel or oil, and this one represents the other. Next sentence says, government bonds should be, now, here we go. It's your first time seeing these, and you got a lot of these in your future. Here's my hint, and I try to stress this, especially when you see it on tests, and everybody forgets this. I always say, write the constraint exactly as it reads, then use algebra to fix it. So this is the easiest way to do these. We need to identify the variables. How many decisions do you think there are before we go on? How many? 5? Yeah, I don't know. I'm asking you.
I see this 4.
I see 1, 2, 3, 4, 5. The decisions are how much money to invest in these only options we have in front of us for the client's $100,000 on these bonds. On these bonds we're converting. We're basically cashing in, we're selling the bonds, taking the cash and reinvesting it in one or several of these options. That's the decision. Let's go with X1 through X6. Okay, help me out with describing one of these. Let's go with X1. Blah, 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 Atlantic oil. Give me the words before Atlantic oil. How much to invest in, that's it. How much to invest in, I forgot the name of it.
Atlantic oil.
Thank you, Atlantic oil. Much to invest. X2 is how much to invest in that one. X3 is how much to invest. X6 is how much to invest in there. We got our variables. By the way,
I get X6.
is it 6? 1, 2, 3, 4, 5. I was counting that investment word. X5, all the way X5. X5 is how much to invest in government bonds. How much? GB, government bonds. You ready? It says government bonds should be at least, let's start right there. Government bonds, X5, should be at least
25%.
greater than equal, there we go, 25% of the steel industry's investments. Of, that's the key word there, of 25% of the steel investments,
X3 and X4.
whatever variables represent the amount of money going into the steel investments, and he says it's X3 plus X4, is that correct? That's both of these are the steel ones? 25% of the total amount going into the steel investments, the amount going to government bonds has to be greater than. Is that how it reads? Now, at this point, you can't have variables on both sides. You have to have all the variables on one side, and you may be left with nothing on the right side, which means it's 0, or some number that's involved in this.
So just divide.
I'm going to first get this simplified, and here's where, every semester, here's where the most common mistake is at this moment right here. A student will divide both sides by X3 plus X4. You can't do that. Simplify it first, because you won't be able to enter it in there. You'll be entering one something over something, and it just won't work.
So do 0.25.
So go X5 greater than equal to 0.25 X3 plus 0.25 X4. Now all you got to do is subtract and subtract, and now you have X5 minus 0.25 X3 minus 0.25 X4 greater than equal to? 0. You have a number on one side, you have all the variables on the other side, and now that's a constraint. But the easiest way to start is you write it just the way it reads. Government bonds has to be greater than, or what's the word being used, not greater than? What's it say? At least, okay. Government bonds has to be at least 25% of the total amount being invested in steel investments, the steel options. Next sentence. How are we doing on time? People are leaving.
You got 20 minutes.
Oh, man, we got lots of time. Here we go. The investment in Pacific Oil, what variable? X2. The investment in Pacific Oil, which is X2, the investment in Pacific Oil, the high return but high risk investment, is that the highest return one?
Yes.
So it doesn't tell us that until just now, but it's also the highest risk. The high return, high risk investment cannot be more than 60% of the total oil industry investment. Let's write it just like it says. The amount invested in Pacific Oil is what variable? X2. Then it says cannot be more than, less than equal to 60% of 0.6 times of, and the oil industry, give me a notch.
X1 plus X2.
X1 plus X2. There's the sentence, right there. The amount going into this most risky investment, which happens to be Pacific Oil, X2, cannot be more than, is that what it says? Cannot be more than, which means it has to be less than equal to 60% of, means multiply, the total amount being invested in oil. Is that what it is? Now we'll simplify this. Multiply 0.6 times each one. Now, watch this. I'm running out of room. Has everybody got everything below this?
Yeah.
Here we go. Watch this because you have common variables now. x2 less than equal to 0.6 x1 plus 0.6 x2. Subtract each. Common variables. What's this?
0.4. Oh, wait.
1 x2 minus 0.6 x2 leaves you with 0.4 x2. Subtract this. 0.6 x1 less than equal to 0. 0.4 x2, which is a whole x2 minus a 0.6 x2, leaves you with 0.4. And then this, no x1s are here. We subtract it, we get minus. And this can be in any order. You could have put minus 0.6 x1 plus 0.4 x2 greater than less than equal to 0. It doesn't matter the order. It's the sign in front, positive, negative. That's what matters. Whichever order you want to go in. Okay? Yes.
I have a question on restriction number 2 for the government bonds.
Yeah.
It says it should be at least 25%. It
Yeah.
doesn't say it must.
Yeah.
Does that mean I have to or I don't?
Once we get our optimal solution, if you want to make an adjustment to stay within at least should be, it's giving you the order to do so.
Yeah.
You can't make adjustments till you get into upper management, right? Because, this isn't your money.
Yeah.
All right. You ready? What portfolio recommendations, investment amounts should be made for the available $100,000? Wait a minute. $100,000. Isn't that a limitation?
Yeah.
Less than equal, greater than equal?
Less than equal.
Less than equal. Uh-oh. Here you go.
Plus the other.
It's never just one. Wow. Just pens.
You dying on
Dead. The pen's done. Hang it. I gotta go with red, you guys. I'm running out of colors until I get some new pens. Is this new or old here? Here we go. Capture a man, I forgot. Wait a minute. This is an objective function. This is a constraint. We haven't even done the objective function. Less than equal to what? 100,000. Over here has to be, these represent how much we're going to invest. So this is in money, I guess, right?
Yep.
And that's money. So there's nothing to do to these. They already represent how much we're investing.
Right.
But when we add them together, they got to be a lead or less than 100,000 or equal. So how many are there? 5?
Yeah.
x1 plus x2 plus x3 plus x4 plus x5 have to be less than equal to $100,000. Sound right? Now our objective function. They want you to maximize the expected annual return from this investment. Max is correct. The variables have to represent the expected annual return. Do you see those? Tell me what I put with x1.
I can't see.
What does it say? 7.3%. We got to use decimals in this case. Where am I here? 0.073 x1 plus 0.1? 0.10, 10.3%. x2 plus 0.064. X3 plus 0.075. X4 plus 0.045. X5. However much money gets invested into each one, multiplied by their expected yearly return, needs to be added up and be maximized. That's what we're doing for the customer. And stay within 100,000 and make sure. Did we do this? Did I erase it? Darn.
Yeah, you did.
And the rest of the deal. Everybody with? Got it? I'm going to post the answer to this, by the way. All of these that we're going over, I'm going to post the answers. Remind me if I forget. Okay, let's do the answer for this one. This is the financial one. And let me think here. This one we're doing on the software. How many, which module are you using?
Linear program.
Linear programming, okay. And we haven't even used a different module. File, this is new. How many decision variables were there on these finance decisions? There were 5 of them. I can't remember how many constraints there were because I erased them. Everyone else have 5 too?
Yeah.
Yes.
Okay, here we go. Max or min?
X.
All right. Those are the variables, and look at that. Oh my. Magic. There they are, 0.073, 0.103, 0.064, right there, however much we invest times those numbers. Look at different variables. All of them added together, however much we invest. So the government, what is that, government bond thing? Is that what it says?
Yeah.
I want to see, did it say the word money market in it? No, it says government bond. It's basically saying, and I'll read this again because I interpreted that we need to invest up to 100,000. I was assuming that if we don't invest every penny of it, the little bit that's left over being like in a savings account or a money market fund or something like that. But let's see, the portfolio recommended investments and amounts should be made for the available 100,000. Let me read up here.
It's a mutual fund, so there's no savings.
Yeah. Well, I'll have a money market fund, the same as the savings fund. So the only thing we got wrong here is we need to invest every penny of it. We gotta make this an equal. Every penny's going to be invested. Now let's go back to the answer. Here we go. We're investing 100,000. We're making sure that no more than 50,000 is in the oil, no more than 50,000 is in the steel, and the little bit where we have to have 25% and 40%, blah 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 blah, right? Or 60%, whatever it was. My question for you is, how much money are we investing in Atlanta oil? That's my question. How much in Atlanta oil? Hit me.
20,000.
Anyone disagree? Is it 20,000? 20,000? What variable are you looking at, Chase? Up there on the screen, I mean.
Pacific Oil can only be up to 60%. So.
No. Which variable is he looking at?
A.
A. That was it. A, in this case, represents the Atlantic oil. So if I said, how much are we going to invest in government bonds? 10,000. What letter? G is representing government bonds. Here, how much is invested total when you add these up?
All of it. 100,000.
100,000. You don't even need to add them up. We've said all of it has to be invested. They got to add up to 100,000. How many binding constraints do you have out of the 5 constraints? 4. Right. What else? That's about it. How much money are we going to make for the client with this combination on this $100,000? And that's the most we can make for them and stay within the limitations that will be given to us. There may be a slightly different combination of investments, but it will not achieve anything above 8,000. That's it. That's the most we can get. Yes.
So if we could invest less than $100,000, is it possible that we can make a higher objective funding value?
No, there's no way, because every penny that's invested is making money, which is in the objective function value.
So there wouldn't be any other combination possible?
There is another combination, but it won't get us any more money than 8,000. That's the. If there's a different combination of how to invest it, that's the highest it will get us. So we might as well go with the answer being recommended, since we can't get any higher unless there's a reason not to go with the recommended. It's called an alternative optimal solution, but it never gets you a better objective function value. Everybody know how to interpret this, right? How much do you invest in each one, blah, 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 because your next quiz is not only give me the linear programming model, which means give me the variables, define them, give me the objective function, give me the constraints, but you're also going to have outputs, and you're going to have questions where you're going to match the variables up to the story, and it's going to say how much is going to be invested in oil. On any oil option, you're going to be looking at 2 variables, because there's 2 of them that are oil, and add it up. How much will be invested in the government bond? You got to know where to look to find that answer. What's the amount of money, the most money that could be made on these investments? And you're going to know to go to that objective function. These are the kind of questions you're going to get now when you see this output. It's not going to say, hey, right now we're making 7.3% and it's going to be, we now realize it's going to be 9%. That's chapter 3, even though I love that question. If this goes from 7.3 to 9, are the optimal solutions still valid? Because we're inside the upper limit. Very good. What will happen to that objective function value? Will it go up or down? Okay. Jim? Yep. Nope. Mark? Hit me? Okay. All right. What day? Hang on a minute. What is going on here? So we can start it? I missed it. What did I say? I actually forgot what I said.
What's that 9.4 like?
Oh, yeah, okay.
That would go up.
If we find out that the expected return is not 7.3, that it's 9, is the optimal solution still valid? And we heard yes because it's within the upper limit. And then I said, would the objective function value go up or down if that change were to take place? Up. That's right. These changes in the objective function, the direction they go in is the direction that goes in. It's these changes in the right-hand side of constraints that may go up or down. Look at this. Is this our first negative dual price right here? Shoot. Wow, I almost want to talk about that. Just to prepare you for the final, because you won't have that on the third or fourth quiz. But, man, there it is. I wish we had time to talk about it. We got one, what, 10 minutes? We got one more, though.
What?
We got one more.
Slow down.
Really? You don't want one more?
You're going crazy.
Let's go to the in-class segment. Was either another example or in-class? Another example? I'll call the audible now.
It's like another example, do we have to do the in-class
No,
assignment?
it's one or the other.
Let's do the
Audible.
example.
Which is- You need to embrace the in-class assignments. You need to embrace them and hug them.
But you don't need to do the in-class. You already have attendance.
No, I don't need it. You need it. It's your grades I see. What does 100 on an in-class assignment do to your grade?
If it's a non-detailed, yeah, if it's a non-detailed.
Well, let me look at it first.
Let's just do the example.
Oh, that looks detailed.
Let's detail.
All right. Look. Again, it's not moving. Man, this one's a hard one. Hang on, let me see how much time we got. We don't have time. This is a hard one.
Yeah, we do. We'll make.
There's a couple out here. I want to tell you real quick. See this one with the wings? The airplane, the workforce assignment, building this huge wing. This isn't easy. I want you to realize, if you decide to look this over, more power to you, but don't expect something this hard on the quiz. You can't talk me into it. Stay on board. What happened? How'd that switch? Did I have this up there? Accidentally. Now this one is production scheduling. This is a really good one, but we don't have enough time for it. Let's do the in-class.
Over it though. Or we could just go home early.
I like that idea. Let's do that. Have a good weekend. Homework will be posted probably tonight if you want to get started early.